We start with the next session. The session is called How Semantic Search Projects Fail, and it's done by Roman, who always shows a great sense of humor, so I'm looking forward to this.
Yeah. Hello, my name is Roman, and today we're going to discuss usual pitfalls when implementing semantic search. Like it's a trend of doing realistical semantic search talks and buzzwords and MICES, and in the same trend. A couple of words about myself, a long journey through computer science, machine learning, and quant trading, credit scoring. Last couple of years, it's e-commerce search, originally with a focus on personalization, learn to rank. Right now, I'm doing food search at Delivery Hero with a slight focus to neural networks. And I'm also maintaining a couple of open source projects. It's one of them is MetaRank, is an open source learn to rank service. And the second one is my take on building a Lucene search engine, which like done right. Okay. Sorry. So I'm working for a company called Delivery Hero, and Delivery Hero is a last mile food and groceries delivery, ironically not operating in Berlin, but having headquarters in Berlin. So, but we have a lot of different apps in different, like 70 countries, and it's 20 languages and more than 1 million restaurants and vendors there. So we're quite big, but you can't order food in Berlin through Delivery Hero. And the majority of talks about vector search, especially coming from vendors of vector search databases, are usually struggling from survivor bias. So you tend to share success stories like positive past, but if something is not working, you tend to not to focus on that much. So that's what we're going to talk about. So at first, we're going to talk about, do embeddings matter? Does it just, you can take embeddings from OpenAI and they will work or not? Maybe open source, maybe fine-tuned or something. How could you do relevance tuning with semantic search? Because with lexical search, there are boosts, synonyms, queries, but in semantic search is just vectors. How it works well if you are not searching in English, like spoiler, not good. And the last but not the least is that semantic search always returns products. Even for the most bizarre query, it will find something, even when it shouldn't. So how you should deal with this? At first implementation of our semantic search was for a quick commerce, so literally just a groceries delivery, because it's the most struggling part of the search, because for restaurants, it's usually a lot of head queries and they're quite short, and the inventory is not large because it's just restaurants. But for quick commerce, you're searching for products across millions of vendors. So we have like 20 million products written in 20 different languages in our inventory. And you're not just asking for an overview for something sweet in a vendor. You ask for a specific query, which is usually long tail multi-token. And we had a very huge zero result rate. So we should do something with this. And if you do it with a classical approach, you just have Elasticsearch, you rank top-end candidates, and you can have a very smart ML ranking system to do, but if you have nothing to rank, it cannot do anything about it. So you still need to focus on recall and retrieval to make it available for further re-ranking, for precision optimization. And this balance between the precision of recall in lexical search might be quite tough. So for example, you search for Coca-Cola Zero, and ironically, it's called not Coca-Cola Zero, but Coca-Cola Light, and you won't get any results. But you can relax this query and have it not just and cola and zero, but or cola or zero, and it will match Pepsi or zero calories cookies or something else. So it's kind of not a wrong balance. You can ask your content team to make your dictionaries of different synonyms from different languages, like 20 languages, 70 countries, different vendors. Good luck doing it in production. But technically it's possible if you're like a mono brand or operating in a single country. So a couple of years ago, there were a lot of different positive talks about semantic search, and all they were coming usually from database vendors of semantic search, and they were looking like this. You embed your documents, put a vector search database, and that's it. What we actually try to do, will it work? So this is like an example search query we did for a query called tomato. It's an E5 multilingual model. And I'm asking you, this search results seem to be relevant for you, like in major part? You can raise your hand if you think it's relevant. Yeah, when someone thinks it's irrelevant, we're waiting for things. So if you overlay it with actual customer behavior for tomato query, you won't believe, but people are actually buying tomatoes and not tomato rice, not ketchup, which is kind of an obvious for you as a human, but it's not obvious for a model because it doesn't know the intent, because relevancy is subjective. It's not deterministic. It's not just the same for you have a query, you have a document, but the relevancy is not deterministic, and there is also customer intent, something third, making it subjective, and your embedding model has no idea about your audience. And in some cases, maybe ketchup is relevant, maybe not, it depends, maybe in your case it's relevant. So maybe we can try, bigger models. So we took like E5 small, we can just go further to OpenAI embeddings. I have a live demo here, so let's just switch models and see what will go on. So let's, yeah, that like dumb ways to die to do live demos on stage. But yes, so you see that it's more tomatoes if you switch to a bigger model. Maybe you can go for the larger model, but there's a lot of cans and not that much of tomatoes. Here a cherry appeared, and you can switch to OpenAI. I hope it worked because it's not doing. Oh, it's not working. Okay, whatever. It's disappeared from there. Okay, so but it's still going to be just tomatoes and cans. So which doesn't seem to be very relevant in our use case. Even there are some funny queries like water with gas, and you'll get a gas canister on the first position. Why? I don't know. There is gas definitely, but it doesn't seem to be relevant for a query for water with gas. It's like a pre-trained model. Okay, so it seems that the larger the model, the better it can catch some minor details, minor objective details between your search query and a document, but still size doesn't really matter if you're speaking about customer intent in your case, because it's very subjective. So you need to do some sort of a tuning to, like you do usually originally for lexical search, but in lexical search, you do relevance labels, like to have some sort of a baseline, are you improving or not, and tinker with retrieval. And surprisingly, in semantic search, you do the same thing. You start with relevance labels, and then you start tinkering with retrieval, because otherwise you might get in a situation when you're trying to evaluate this looks good to me at position 10 metric. So we did a couple of variations of our semantic search model, show it to our product managers, which are like experts at search. And after checking that for a couple of hours, they say they all look good. And like, so what? So if you're not using Cupid, we highly recommend it. We tried using it on a smaller scale, on a larger scale, and like I'm a big fan of it. So I'm trying to promote it everywhere. So if you cannot improve your search if you cannot measure the improvement. So, but what about relevancy tuning for semantic search? Because for lexical search, you can do boosts, you do synonyms, you do queries, but with semantic search, you can do a bit further and try to do like a fine tuning. Not like going training your model from scratch, because for me, it seems like a bit of an overkill, but because you can take existing model, which already knows something about relevance and just adjust it for your particular use case and customer intent, like for food. So fine tuning itself, it like an aligning model, it's understanding on what is considered relevant, what is considered irrelevant. So for example, we have ketchup and tomatoes on the same distance from a tomato query, and you make tomatoes closer to the query tomato and ketchup further away. But you might wonder, you need relevant docs and irrelevant docs to train your model. Where are you going to take them? You can take them from Cupid, but it's going to be very expensive and very slow because you need like tens of thousands of labels to do this. We decided to take another way. So what we take an implicit labels and train a semantic search model on top of that, but it's kind of not going to work that easily because in some cases, there is just too much noise. So for example, for this tomato query, you have tomatoes with 100 impressions and 40 conversions. So you can see that it's kind of seems to be a good thing to consider it positive. This tomato rice is not a good thing because there are a lot of impressions, no one converts on that. But these two guys on the top, like 3 impressions, 1 conversion. Is it like a 33 conversion rate or not? You're not really sure in that. A couple of years ago on Haystack US, there was a talk from René about this bias correction for conversion rate. And the idea behind the math on the stock is that you can mix your prior and posterior, like expected conversion rate with an actual observed conversion rate based on how confident you are on this observation. So in the case if you have a very low confidence in this, you just shift it towards something like expected, like an average conversion rate for this query. If you have high confidence, you don't shift. So in these numbers, it looks like this. So these two guys on the bottom are still having the same high conversion rate and low conversion rate as expected, but these two on the top were heavily shifted towards an average rate. So we decided then we just bucket that. So these two, we have no idea what's that. And these two are positive and the negative samples. Of course, there are some risks doing this, but surprisingly, for at least top queries, it started working quite well. So for example, our tomato query, it was like this, just if you forgot. And with a fine-tuned version, it became like this. So it's finally full of tomatoes. Yes, there are some cans on the bottom, but still looking quite good. Even if you do some long tail queries, it might got worse, like rose. No, not rose, but pink. But still it decided maybe you're peeled tomatoes or something. But for some queries, even for the long tail queries, this gas canister finally left search results. So it seems to be like a relevant thing. And the cool thing is that model was able to figure out from the customer behavior that people in Arabic countries, because it's hot, tend to buy water in big packs and not just into single models, not into the single bottles, because it's just more effective, you know. Next, the problem of this approach is that these implicit labels are very noisy and biased towards popular queries. So, and there are some cases when you have high confidence, but it's still around your expected conversion rate. So you can't really say, is it a positive or a negative thing? And for long tail queries, often just not enough not enough data to reach confidence. So it's the model itself is biased towards popular queries, also biased towards existing ranking because you only use positives and negatives out of your existing retrieval system. It doesn't mean that your retrieval system is correct and perfect for that. But it seems to be working for us somehow. So for future plans, we do plan to focus on this noise because we did a couple of experiments with larger models, like let's take Llama 3, which is the huge, and train it as a cross-encoder on our data from Cupid and ask it as like an extra signal for this labeling. So you don't only use conversion rate, but also a signal from a cross-encoder that it seems to be a positive or a negative thing. Maybe it will improve the situation with the noise, maybe not, but at the end, we'll just distill, like retrain the same model and have it better. Talk to me in like a couple of months. Will it work or not? The second problem is non-English search, because in Delivery Hero, we have a lot of searches which are happening not in English, and you can't just ignore it. But the problem is that a lot of pre-trained models are actually in English in this MTB leaderboard, and even the multilingual models, like E5 multilingual or the model coming from OpenAI or Cohere, they're still kind of not really absolutely equally multilingual, because if you check the paper, this E5 multilingual training methodology. So for pre-training, yes, there was something multilingual, but for fine-tuning, almost everything is just pure English, apart from Miracle and Mr. Tidy, which are very minor data sets on the bottom. And there was a post by Joe Bergom in Vespa blog about evaluating E5 multilingual on out-of-domain data. And it seems to be that if the model's seen this language, it's performing quite well. If it hasn't seen the language, you can see that for BM, it's even worse than BM25. And even for English, but for out-of-domain data, it's still not as impressive as it's on leaderboard. So, and we think that food and groceries domain for this types of model can be considered an out-of-domain data. That's what we observed with this gas canister. But if you do fine-tuning on implicit data, it means that if you're introducing extra, like a second layer of bias to English, because only samples in English can reach this confidence. And these underrepresented languages are still even less than in a traffic. We try to do a couple of hacks. So you just lower the bar for this confidence to get into the training set, but it's a balance between noise and the values, the signal to noise ratio. So you can lower it even more and get even more data, but there is a risk that it's just pure noise. So a demo, I'll try to do it like, I don't know, like how, because I cannot type Arabic, unfortunately. I need to copy paste it. That happens. But you know, for multilingual queries, it's the multi-5, and that's the fine-tuned model, and it can figure out that it's actually the same water. But it's not that rainbows and unicorns, because if you go for something not really typical and present in our training data, like dialects of different languages, on the way you call water in different countries, but not in Arabic Emirates, it's still water on the bottom, on the top, and it's still mayo for some reason. It's like a phonetically close to what's written here, but it's not semantically close. So it seems to be the problem with noise is still there. What we also found is that for mixed language search, because we have inventory in Arabic or Spanish, search happening in English, so it's just all them mixed together. You can't separate traffic for different languages. What we found, we were just concatenating all the titles, product titles, and all the languages we know in a single string, and then embed it and fine tune, and that seems to be working best. Mixing any metadata information for some reason didn't make any sense, I guess because model itself already can figure out that it's a bottle of water out of title. You don't need to explicitly hint it that it's water. Some future plans, maybe we'll try to implement some machine translation assisted fine-tuning. So instead of just collecting the implicit data labels from customer behavior, you just can take English one, translate them to, for example, Arabic or Italian, which are very underrepresented languages in the training data, and then just trade on top of that. It might work, it might not, we don't know, but we hope that it will. And the last but not the least, it's that semantic search always returns products, and our product managers are really frightened of that, because you might search for hello from Mixcamp e-commerce search and it finds KitKat. Why? You don't know, but it always returns results. You can't stop. Eventually, if you do pagination, you will paginate across your whole inventory. And it should be like stopped somewhere. But it can be more clear and practical if you search for something like, for tahini. Oh, it can handle typos, by the way. So for tahini, you see that are actual tahinis on the top, and here you find that it's not anymore tahinis, but some sort of chips, ketchup, all the things, which doesn't seem to be exactly matching your search query. But if you check the scores, it's like 65 versus, let it be 81. So there might be some sort of a threshold. After that, you can consider results relevant. If there is a threshold, it's the same threshold for all the search queries or not. And after just tinkering with the different search queries and languages, we made some sort of a distribution across our evaluation set of the cosine similarities. So, and empirically we did like, okay, let it be 0.7. We did our offline evaluation and find out that it actually is still improving the situation with 0 results, but not as much. Still like 70% of our 0 results queries are still 0 result. So we should do something and go a bit deeper. So we assumed maybe we can do a second attempt, and maybe similar, you need to watch on a perfect threshold for similar queries. So you have an unseen query, but it might be semantically similar to query in your training data. So you can get like these positives and negatives and see how can you distinguish between them. But ironically, that diagram from one of these examples, can you distinguish positives and negatives out of this distribution? We can't, so it can be anything. So it was very noisy because our implicit training data is noisy. So a neural network can extract this knowledge. Out of that, we, by using statistical methods, can't. So we decided to iterate further and find out that it actually depends on the model. If you see this cosine similarity distributions across different models, they are looking completely different. If you start fine-tuning, they start looking even more different, even for the same model, because it depends on the way you train model. There is like an important parameter in the contrastive training. It's called temperature. And usually it's some sort of a confidence model has in giving predictions. It doesn't mean that it's giving right predictions, but it might be very confident in giving this. So most model like E5 are trained with a low temperature. So their distribution looking like this. So it's very hard to distinguish. You can just increase the temperature and distribution starts separating, but overall quality of the model usually goes down because it's just very confidently making errors. So that's the first thing which matters. Also, we found out that the square length actually affects this threshold. So for single token queries, for multi-token queries, these distributions are different. And surprisingly, the longer the query, the higher this similarity. Sorry. And it also, I guess it's related also to language, but only implicitly, because I guess it's mostly correlated with the amount of training data this language has in your data set. So we have less Spanish, more Arabic, and you see that model is less confident in Spanish and more confident in Arabic. But if you do some sort of a balancing your data set, you might get to these distributions to match. So at the end, we went with a very similar, like a table approach. So it's just single multi-query per brand, per language, and it's usually within the range of 0.6 to 0.7, but it depends on our custom model. It might be very different for your use case. And the last interesting point is, does it work? So that we did not just one A/B test because it can be anecdotal, but multiple A/B tests in multiple regions, because our countries are very different on the data quality and the way customers search. So we found here that that's a lot of green here, but you can see that there are two outliers here. The first one, which is seems to be very optimistic. So it's a large improvement in all the metrics. But this is the most lowest baseline country across the whole inventory. So because the inventory of this country is so have so many data quality problems, you need to rely on semantics a lot to figure out what people are actually searching for. And the country on the bottom doesn't have this problem. So it's usually well correlated with your baseline and how lexical search is good. And this is kind of the numbers we get on the body, which are still mostly green, but not as impressive on the first row. So to summarize, yes, no, does it work? Mostly yes, but don't expect it to work in just 1 week. You just embed everything with OpenAI, dump it to vector database, and usually it doesn't work. Because it depends on the baseline, and usually you compare your existing well-tuned lexical search you spent years building with some new model, and it's a very tough baseline to compete with. And actually, this semantic search is mostly focused on recall to retrieve the products which are not usually there in your retrieval, and you need still to do something on top for precision based on conversion rate and so on, like learn to rank, whatever. And should you fine-tune? I think yes, it's not hard, especially there is a sentence transformers v3 released like a month ago. Now it's modern library and not like an ancient one like it was before. That's me on LinkedIn, and MTB leaderboard, I read like a newspaper. So that's it, you can have questions.
Thank you. Any questions?
Hello, Roman. Hello, Roman. First of all, nice talk. Thank you. I want. There is one point in the talk that really gives me like doubting is the encoders are a mean of semantic similarity, but you more than the similarity, like in the example of ketchup and tomato, we're fine-tuning for relevance, right? So this strikes me as a little strange because similarity is a task and the relevance is more like ranking. So I wonder if semantic similarity should be an input and then ranking is a different problem.
Yes, but there is like a retrieval problem and a ranking problem. And in our case, ranking is performing very great, but it has nothing to rank. So you have nothing to retrieve. So you can use some bits of your smart ranking system to integrate it to your retrieval, just to retrieve more candidates for the ranking. And yes, this can be a signal. Also, the similarity can be also a signal for the ranking, but usually ranking is much slower and using much more parameters. And you can't use it directly for retrieval. You can't use ranking across 20 million documents in a reasonable latency budget.
Okay, so you fix having more candidates in these cases and also more practical in terms of efficiency.
Yes,
okay.
Yes, but we also do plan to use the semantic signal as part of ranking.
All right, thank you.
I'm a bit confused. Did you always use a hybrid approach of lexical and vector search, or your first demos were they just vector search only? Because at the end you said your A/B test was against the hybrid approach.
Yes.
How was the strategy for the hybrid approach?
Like a reciprocal rank fusion with a couple of business rules on the top. So nothing fancy. This is like a more like a demo UI to see what is actually being retrieved by the raw model without any hybrid, because I know what is being retrieved by the lexical search, and usually for long tail queries, nothing is retrieved. So we have another more complicated UI which does hybrid retrieval, but it's only available from VPN. It's kind of too complicated to demo. This is running locally. So
thanks.
Thank you, Roman, for your talk. I'm just curious, like, for example, LLMs, right, they're usually designed to interpret text with the long context, right? So, but usually, let's say description of queries and description of products, it's not like poetry, like, and they're usually short. And have you tried, let's say, simpler models for vector search, like fasttext or word2vec?
Yes, but it depends on the metrics you compare. But on my evaluations, this fasttext model don't take this semantic similarity that much because they're too small. We actually do use fasttext in our previous ranking models. And on my personal evaluation, it seems to be this: the bigger the semantic search model, the bigger is the difference between them in a positive way. But there is still like a balance between how big your model is and how expensive it is to run this model. Because if you go on this MTB leaderboard, top of filled with 7 billion models, which are very smart, and if you fine tune them, they're like probably predict everything, but it's very expensive to run and they're very slow. So that's why we're sticking into some mid-sized models, which are already quite good at semantics, but still okay to run on CPU with a reasonable latency budget. And I have you asked the latency question in the last, I have an answer for you. Yes. I once, I will send you a link for like an article I wrote about that. So, here's the one. So that's even the answer for that. If you scroll to the bottom, there are numbers. Here are they. So maybe like this. So this is E5, but this is like on CPU on my desktop. So like a moderately old computer, it depends on the tokens. So the longer the query, the higher the latency. And it depends on the size of the model. And you always can quantize without that much loss of ranking quality. There is slight loss. You need to expect that. But still, you can see for large models, it goes from like 40 milliseconds for 4 tokens to 9, which is like a good win. So we do quantize, and we're in this buckets, like E5 base, but multilingual E5 is bigger, 3 times bigger than base. So it's like in this size bucket, but it's kind of being within 10 milliseconds for inference is still okay because we're on CPU.
Thank you for your talk, Roman. So my preliminary question is, was the search working on a single field vectorized, the name of the product, what you showed before?
Before, the baseline is actually more complicated. So it's not just a single field. It's like categories, top-level categories, some tags set by vendor, description. So it's like a traditionally well handcrafted lexical search with all these boosts, synonyms, different types of queries depending on the query type. But so it's kind of a tough baseline to build. But I still was struggling on recall.
No, maybe you got it wrong. No, I meant the first model you shown.
Yeah, it's still the first and the last, it's just on product titles, surprisingly. We try to mix description, but it's usually comes to the data quality because on quick commerce, you are like but imagine that you're Reve, you have a lot of product titles, but you're not filling descriptions that well. It's usually just garbage. We tried, there is no improvement. We tried to introduce some catalog data about tags, some classes, like top level, bottom level categories, but it seems to be not doing any much sense.
So let's thank Roman, and I think he'll be around for.
Yeah.